Welcome back, everybody. A brand new space telescope is about to transform our understanding of the universe, and it's almost ready for the launch pad. NASA's Nancy Grace Roman Space Telescope is a first of its kind observatory on mission to map the universe one panoramic frame at a time. And get this, it's ready to go 8 months ahead of schedule.
And so we're taking you behind the scenes for a last look at the telescope right before it begins its million-mile journey to reveal the secrets of dark energy and hunt for distance. Hidden worlds as well. Joining us now is Dr. Dominic Benford, NASA Roman Program Scientist and Chief Technologist for Astrophysics, to tell us all about this technological marvel. It sounds beautiful.
Yeah, incredible. So if you can, Doctor, thank you so much for being here. And we'd like to start with the telescope itself. Describe how it works, what it is, and give us a little bit about what you feel when you look at this instrument.
Well, thank you for having me here. This is an exciting time for us because we are about to bring forward the most revolutionary telescope in a long time. What you see right now is a live feed of the clean room at NASA's Goddard Space Flight Center, where the Nancy Grace Roman Space Telescope is fully complete and is undergoing its last round of optical testing. What you see there, the telescope is oriented on its side, pointing towards the a special mount where we have cameras set up to look into the telescope. Now, what makes this telescope unusual is that even though it has the same size as the Hubble Space Telescope, and therefore the same incredible, exquisite sensitivity and sharpness of image, it has a field of view 100 times larger. And it is 10 times more agile, so it can take pictures much more rapidly and map the universe 1,000 times faster than has ever been possible. And with this, we will begin gathering data at a phenomenal rate and making discoveries of thousands, millions, and billions of new stars and galaxies.
It sounds incredible to even wrap your head around this telescope, and I love that we were able to get a live look of what is a size of a semi-truck trailer with the camera the size of a refrigerator that we read about as well. Tell us a little bit about the cutting-edge technology that you mentioned just a little while ago, and how important that is, and really how awesome.
The Roman Space Telescope brings together a set of technologies, all of which were individually being prepared and then have been brought together in one new observatory. What you see there is the fabulous telescope itself, which has such a wide field of view. Coming into it is the wide field camera, again, about the size of a refrigerator. It has a 300 million pixel infrared camera, perhaps the largest that humanity has ever made. And all of this brings together a capability in an observatory that can rapidly point to new parts of the sky, take images, and radio all that data back across 1 million miles of space to the Earth, where it will be processed and made available as quickly as possible. All of it goes public as soon as it is taken. And so anybody anywhere in the world can use this to make discoveries. And we have planned a number of surveys that will make transformational observations of the universe, and everybody will have access to that data.
Mm. Tell us more about those specific surveys. What specific things are you all hoping to learn from this telescope?
The Roman Space Telescope is a survey machine. It was designed to conduct surveys where we can image much more of the universe much faster than ever before. And so we have designed it with a great capability. How we will use it depends on our time. For the beginning, we're going to begin by looking at the universe and mapping wide swaths of it, many, many thousands of square degrees, imaging billions of new galaxies and measuring their evolution across cosmic time to trace dark matter and dark energy, which are the two dominant components of our universe and about which we know very little. We will also survey within the center of our own galaxy to look at hundreds of millions of stars and count the planetary systems around those stars for the first time. And we will use it to measure the number of stars in our own galaxy, the Milky Way. We will create a catalog of perhaps 20 billion stars that have never been seen before, and it will be the largest catalog of new astronomical objects in humanity's history. And that's just the beginning. We will do all of that within the first 5 years, and
Wow.
the mission should last much longer.
We mentioned hidden worlds too. Are you expecting that?
Well, we think that we are going to find hundreds of thousands of new worlds around other stars. Many of these will be discovered by the techniques that have been used in the past that tend to find planets that are large and close to the star, but a lot of them will be relatively far from their star and colder, much like our Earth is. And what we're really trying to do is find out whether planetary systems like our own solar system are common or rare or perhaps even unique in the universe. And we will discover this with Roman.
So this is all ahead of schedule. We want to note for our audience, 8 months ahead of schedule. So talk to us now, what's next, especially given that you're so ahead?
Well, we've designed the Roman Space Telescope with technologies that we knew how to build, and so we planned well and have managed to keep it on track. And we will be launching it ahead of schedule, roughly this September. Now, it's currently, as you saw, at the Goddard Space Flight Center. Next month, it will be packed up and sent to Florida, where it will launch from the Kennedy Space Center on a Falcon Heavy rocket. It will then take about 3 months to get out to the second Sun-Earth Lagrange point, which is a location in space about 1 million miles from the Earth in the direction away from the sun, where everything is cool and dark and stable. And when we get there, we will begin observing the universe from its relatively useful vantage point, where the sun, the earth, and the moon are all on one side, and so we don't get interference from them. And we can begin mapping the universe faster than ever before. All that data gets sent down and into our archive at a rate of about 1.5 terabytes per day. And just for scale, over its entire 30-something year lifetime, the Hubble Space Telescope has returned an archive of about 200 terabytes thus far. The Roman Space Telescope in its first 5 years will be about 20,000 terabytes of data, vastly more than has ever been presented for this kind of observatory.
Wow, Doctor, we could keep you here all day with questions. Thank you so much for giving us a first look at this, for the data, the context. We're excited to watch as these discoveries start rolling in. Doctor, with NASA, thank you so much for being here.
Thank you so much for having me.